Okay, welcome back. If everything is kind of going according to plan, homework 2 is done. Don't have to worry about it anymore. We can move on to project number 2, where we're going to use a combination of our skills of like loading in data and analyzing it, like looking at histograms. You could even create box plots if you want to try to understand what's going on. But some kind of data analysis, turn that into predictive analysis, like a Monte Carlo prediction. And this is actually how shorting stocks works, where like if you think the price is going to go down, you can solve like this kind of problem. Really use like a differential equation, but Monte Carlo models, they can predict they are one way of solving differential equations, but you figure out like what is, given the data that we have, what's the likelihood that it's going to go down and by how much, and then agree on a price of like, this is what shorting that stock would be worth. And yeah, I am not a financial advisor, so that's about all I know about like shorting a stock. It's kind of a random walk prediction. But if I take like all this data, load it into, take that big comma separated value file from all this New York Stock Exchange data, there's 851,000 data points in here with all 7 columns worth of things, opening and closing prices, the low, the high, the volume, like how much volume was traded. Then I start looking at least for my analysis, I looked at Google, and here our data goes right up until last day of 2016. And what I wanted to do with my analysis when I was going through this was just look at what can go wrong. So I did not include this big drop in 2014. And in that day, I think Google company split. Like I think it was Alphabet and Google at that point. So that's why there was a big drop. And I knew that my model was not going to capture that drop if I didn't include it as part of my training data. And if I look at the changes in price, so the actual like price of Google data, or sorry, Google prices, coming back up. Oh my God, come on, come with me. You can kind of look at this and maybe say, I don't know, it's a parabola, like this red upward curve or something. Like it seems like there might be some kind of trend to it. So the random walk hypothesis for this like stock market is that if I just look at what was the change in price every day, that is a random number. And depending on your philosophy and how much you believe that the world is random and full of chaos versus like ordered and every effect is due to a cause, maybe you don't believe in that it's random, but no matter what you believe, it looks like it's somewhat unpredictable. Like even if you know everything that's happening, it's hard to predict based on this big jump that 2 days later would be a drop. Yeah.
Where do we find the project? When I go to Jupyter, I click on the project and it just says page not found.
Page not found. Oh. maybe you just gotta look harder. Like, tell it to look harder. It's because it's a 3-year-old looking for the project. Oh yeah, all right. So I already have the same. I'll have the same problem too. So it'll tell you like 404 not found, like big same thing. If you look at the hyperlink up above, you could add a .md to the end, and then it'll bring you right into. It'll bring you to the project. And if you want to make sure that every time you're on that page, it always brings you there, like you don't have to add that .md to the hyperlink every time to the URL. Is this all like Greek to you? Does everyone knows like URL, hyperlink? Okay, yeah, I'm not trying to be like impressive with my knowledge of the internet or anything. To the URL? Yeah, .m. Yeah, M is in Mancy. No, like mango. Yeah. Mango, man. So what we can also do is like actually edit this link. So general structure of that markdown link is like brackets are what the text is going to show, and then in parentheses where it's supposed to send you. So add that MD to the end of that like parentheses, so that now every time you click this link for random walk predictor, it'll bring you to project. Yeah, that's a good place to start. Like, how do you actually open the project? That's a typo on my end. Yeah. Because if you don't, whenever I'm building the actual website, I don't need to add that MD. It's just gonna find it for me. So when I was clicking through the website to make sure it all worked, it's like, oh yeah, everything's fine. But yeah, I just forgot to add that. It's not that you should know. You should have known beforehand how to find a file in this like Jupyter notebook sort of thing. But now once I added that MD, now it'll bring me right into the project. Now I have it open like 3 tabs. Cool. And now you should be able to like run through it and see same kind of analysis that I'm going through. So the delta prices here, theory is it's random. That at least the random walk hypothesis is that it is random. And if I know nothing else about the data other than it's random, but there's some, like I think it's mostly random and not totally random, then best thing to do, at least in my opinion, best thing to start with is say it's a normal distribution, because it usually works pretty well. Sometimes not so well, but at least in this case, if I believe hard enough, the blue bars match my red like normal distribution. And once I have like a normal distribution, really it's just described by a mean and a standard deviation. That's all the data that I need to create that. And then I could start creating my own changes in price. So now I have like model predictions that match the same data as my Google data, and I can add up my own changes in price and kind of rearrange how things are working. And as I sum up all those random steps that I took, I get all these different curves, and I can make as many curves as I want for like Google data. I'm extending it like for the entire data set, even though I only use this data to find the mean change. That's why mine keeps going up, but meanwhile it dropped there. Dropped right in that 2014, March 2014, something like that. And coming along. Cool. Now I've got a model. It seems to work. It works really well for the beginning when nothing changed, which is the starting point. It's always going to be the same starting point. And it works really well for the end of wherever I predicted. Like the error is going to be almost zero for the average compared to actual price. What about precision? Is this a precise model? Is this a precise model? No? Why not? Yeah, yeah. And here I'm using like standard deviation to look at error bar. So although it's very accurate at that end point, it is not very precise because I predicted that it was going to be, let's say, $1,200, but plus or minus $400. That's a lot. That's a big change where I'm talking about like a third of the price in error bars. And that's just describing like 67% of my predictions. If I want to include like 95%, now I'm talking 50%, like 60 something percent of my prediction is error. So not very precise, but very accurate. And then and then for your work, so I kind of went through like my own thought process on how to do this. Next step is do it for your own data set. So we've got once it catches up with me here, we have like all these different stocks that you could look at, and you could do the same kind of data exploration, some kind of segment. I like that process of like splitting the data into something that I want to train versus something that I want to predict. So now I've got a comparison for before and after what was included in the training versus the testing. If you want to do it differently, you can try something else. But somehow think about like those questions of like, is it accurate? Is it precise? If there are changes, things out of the scope of this model, is there any way to include that? Like why would it need to be included? And the main thing is like numbers. We need like quantitative comparisons. Yeah.
For the 1.5, are those questions involved just the thought, or do you want that?
Those you don't have to answer for Google unless you want to. Like if you want to try like looking at my analysis and interpret it, but definitely for your own like analysis. Like, yeah, what are the caveats? If you don't want to say 2015, you could say some other time. But something like if you're making a prediction, so you're creating a model, you're making a prediction, you can test that prediction. Like how accurate was that prediction? And then also how precise was it is another good question. Cool. Well, that's project 2 in a nutshell. Any other hiccups so far? I know we couldn't find it in the first 10 minutes. Well, 20 minutes. But now we found it. Anything good happen yet? It would be a lot to try all of them. I would start with one. But yeah, if you want to extend it, compare it, stop. Oh, sorry. So you have to do one column. One double and then now I need to look at those the same spot. Yeah. You start trying to make socks. Yeah, yeah. I know. It's like idle. No, it's fun. So oh, nice. Yeah, yeah. Yeah, mine's a little different, right? Yeah. Yeah, what changed? What do you think is different between mine and now? So like look at that black box and that and like SE shade. Yeah. And then look at mine and mine is so here I'm only flying, at least in this little bracket, it's always 3.5 Hmm. So if you're looking at like your own analysis, it looks a little different from like my final graph, because what I was doing here is I created a change in price for every day in the data set. So coming back up, like our main model is kind of D-price model. Don't want that. So this is my main, kind of the backbone of my Monte Carlo model, is that for every day in my Google data, I'm creating a random change in the price of Google data. So I think in your notebook, this is length of Google data, but pre-2014. And now this is going to be date of pre-2014. So now if I just look at that, now I'm only looking at changes in price over that 4-year period rather than all 7 years. Yep. And then in here, I'm going to change this one to and now I'm comparing like the total New York Stock Exchange data from 2010 all the way through 2017, but just looking at the data that was used to build my like change in price model. Or I could compare it like just apples to apples. Now I'm back to same kind of analysis that you have. So the main goal is like you're gonna build your own like random walk, and then interpret. So that day by day is how it's there. That's something that you want to look at. Your cloud model match. Yeah. Like a black line. Which one did you use? Forward or backwards? Yeah. So in general, I'm like I prefer to plot everything, and just made me think of this as we were talking about it. But I did see over the summer a demo of Great Tables, which is like another Python sort of thing. And some of these actually like look pretty good, like this like color varying table, um, and some of these where it has like all the different variables and like time varying stuff. Like some of these tables like I could get behind, but usually like for just a general, hey, here's a whole bunch of numbers to stare at. I don't get a lot of information out of that, but something like this bottom one, that one's pretty good. Sales of coffee equipment. But anyway, great tables. If you're into tables and like analyzing data, great tables is a great place to start. Kind of looking at what can be done with Python and data visualization. right now we're looking at, as we change the number of years that get plotted, sometimes it includes the year and month, other times it includes just the year. So we're trying to figure out, is there a way to change the X ticks? Ooh, look at that. You could have like year and then mid-year, 2005 July, 2006 July. How do we do that? Oof. Oh wow. Yeah, this is not straightforward. I don't know. It's not a quick answer. Yeah. And that's okay. Yeah. But I feel like there should be a better way. Number of ticks. I don't know, this one's not working for me. Locator params. Oh, for date locator. I think because it's dates, it's giving us a problem. I don't know. Yeah, it might just end up sometimes being a little messy. That's okay. Yeah, there's no quick option. The only way is like manually figuring out the start date, end date, and then splitting it up into the dates that you want. And there's all sorts of answers to figure that out, but yeah, I don't know. It depends on how much money we're getting paid for this. So right now it's 0, so it's if it's not an extra parameter, then but if you get hired as a consultant and you're say like we need this, you can say, all right, give me 3 days, $500. Now you know. And you can create any kind of interface they want for it. Thank you. Have a great weekend. All right. Have a great weekend.